So I'm taking a short break from the VLAN series that the last 2, 3 videos were on. And what I would want to focus on in this video is about a recent post that I made on LinkedIn and on Twitter about having my own set of smaller scripts that do my CI/CD pipeline. The idea here for this particular video is to expose simple, built-in tools that can give you a full-fledged, ecosystem or a suite of deployment. Agreeably, you need to know Jenkins or any other Argo or something of that sort to be in the same league as when you work with a larger organization and everything. But what generally gets missed is these tools that actually let you know the fundamentals of how things work, right? So that is probably the one thing that you don't find a lot of videos on. So I thought probably I can throw some light into it, and for the ones that are interested, you can further look into all of these things. So how do I go about it? There are just 2 or 3 very small components here, right? How do you know that something needs to be deployed or something needs to be built? That is part of the CI and the CD, right? The simplest way to do it is watch a file for changes, and whenever a file changes, you do build on it, which is a compile or a transpile or anything as the ecosystem means. Like say if it's a TypeScript code, you do a TSC compile. And if it's something like C, you do a GCC or a clang build. And in Python, you don't really have anything, so it's just Python run again. In the case of say your a Java system, it would probably be a build and then to deploy, right? Now this is in some sense missed out in a lot of ecosystems. For example, when you start a Node.js Express API, right? Express ecosystem, or for that matter, the Node ecosystem comes with something like Node1, where you do Node1 index.js, and whenever the file changes, it restarts it, right? So you generally do not know how Node1 works internally. It basically looks into files, it observes file changes, and then triggers something. If you want to do sort of a shift from node 1. Node, as a matter of fact, from node 18 and above has a node watch mode, wherein node double hyphen watch and the files path would actually start listening on the file for changes. And whenever there is a file change happens, which is the file gets saved with the new content, it reloads the process, right? If you would want to understand how this entire thing of the node watch and everything happens, even for example, if you say that you don't want to use node 1 but you want to build your own way of doing this thing, let me know in the comments. It's a very small change on fs events that can be plugged in with, like, say 5 to 10 lines of code within your binary itself, your node script itself. So going to other environments, for example, if you take Tornado Web has a watch mode, wherein whenever the file changes, the server can reload, right? Do you have something like that for C? We don't really. Do you have something like that for Java? Java by itself is not used in itself, right? It generally comes with full batteries included frameworks like, say, your. I'm really bad with Java frameworks, despite that being my recent employment stack, right? Uh, or for that matter, something like PHP. You do not really have a reload, as far as I understand. Probably there is something in Laravel, which is again a framework that brings something. Right? So how do we do this? I have been saying that, hey, it's a built-in. It's a built-in. Technically, not a built-in at this point in time, because you generally use something like, say, fswatch or iNotify wait. Right? These are two ways to do it. What it does is it watches any changes on a particular file's inode and then triggers something. So how do we go about with fswatch? Right? I'm just switching to the terminal, and I'm on a Mac. I could do something like brew install fswatch, I would link to all these programs and their install scripts and everything as part of the description in the video. Right? fswatch is already available. Now, how do I do this? fswatch. So this is how you do it. So you provide the path that you have to watch for with the O flag. I will have a detailed note on what the flags for fswatch also mean in the description, or a secondary, a post to go on with, a reader post, so to speak, right? And then you pipe that into some kind of a loop. So you read from that, and once you read something, you do something. So this is a very simple, straightforward thing. Now, there is another way to do it, which is iNotify wait. I am not getting into iNotify wait because there is a bit of a concern with respect to platforms. FSWAT generally is a very platform agnostic way of doing it because it abstracts out all the requirements between Windows, Darwin, which is macOS, and Linux, GNU Linux. So we can start with, say, fswatch. This is the first part of the entirety. Second, how do you say that, you know what, I need to do a continuous deployment? Okay, you need something like Jenkins, which picks up the changes from your Git repository, and then it pushes things into your final destination, right? It could either be that it picks everything up on the Jenkins machine, it does the build, it takes the assets and finally deploys it to the final destination, or it does it on the destination itself, depending on where you think your resources are better suited to. Now, we take this entire idea and we narrow it down to the core elements that are part of it. What do we need here? We need a system that knows, hey, my changes have gone into my version control system. So push the changes to somewhere else and do something on it, right? This is what something like your GitHub Actions or your Bitbucket runners also do, right? How do we do that here? We go about with what we call a bare repository in Git and a post receive hook in Git. So what is a bare repository? Bare repository is something where your Git structure is there, but there is no code base attached to it, or rather your version controlled content is not directly sitting there as such, right? Okay. So what exactly does it do then? Its only job right now here in this entire setup is to say that, hey, I have a history of changes that are coming in. And when I receive the changes saying that, hey, the changes are received, go and do something. And what exactly should I do will be defined by the post receive hook. Similar to how you look at something like a pre-commit hook, wherein it runs, rather Git runs that pre-commit hook, which is a script, and it does certain operations. And when the operations are successful, it goes ahead with your commit and finalizes it. For example, you have linting rules. In your TypeScript, you would naturally have your TSC, TS config that defines your linting rules, basis which you go through all of these and you see errors as and when you write some code. But you also have this as part of your pre-commit hook, wherein even if somebody removes their TS config or empties it out or something, but what it does is it runs the TSC on that, ensure that the exit code from the TSC is successful, which is 0, and only then will it go to the commit. So how does it happen? You make some changes, you commit it, you have a pre-commit hook setting, which is basically an executable script. That's pretty much it. Nothing fancy, nothing complex there. Once the pre-commit hook runs whatever it is, it returns the exit code, which is a success or a failure based on the operation that it does. In this case, let's say it is TSC. If there are no type issues or anything of that sort from TSC, then it returns a success. And what Git does is looks for the exit code from this Git pre-commit hook. Once the pre-commit hook gives it a success, which is a 0, the exit code, then it applies the commit. Otherwise, it fails the commit. So whatever you've added will still be there. Your commit message that you've typed out and saved would not go through. Because what it does is it runs through this entire process just before it starts to commit that changes to your version history. Why do we need this? As you already know, is just to ensure that the code that is going from your end to some version control and then gets merged into the code base, even before it gets to the point of getting merged into trunk, is ensured to have some bit of quality in it. Of course, you could go into your Git pre-commit hook and then comment out everything, or at the very beginning of the script, do a return zero. It will solve everything. You don't have to do anything. Nobody will know, but it will start failing at the integration end. So these are two things, two parts of the equation. What I mentioned right now is the Git commit hook in elaborate. There is another hook that is called a post receive hook. So when does it get triggered? Whenever a Git repository, you do a push to it and it receives the changes, this script runs at that point in time. So we are going to employ these two to ensure that whatever code that we push in gets checked for changes, built, and then deployed, or the other way around, depending on your system. For example, when I'm just trying to do something like a very minimal C program where the first thing would be to pull the changes or deploy the changes as it were, and then build and run it, right? So this is how it is going to be set up. What do we need to know here? Some bit of understanding of how Git works. I will be linking a very good GitHub gist, which has a really long explanation of this entire process as well, and a pre-commit hook, which is an example pre-commit hook. I would also add further resources in the description, so you can go ahead and try to play around with it, create a repository, and do things. There is one more thing that you really need. Where do you do all these changes and where do you deploy to? Which is basically some VPS you would probably need. Because when you look at all your work, you would probably be doing something like you have a DevOps team that has already set up all the infrastructure around it, either A via some kind of a Jenkins slash GitHub Action slash Bitbucket runner sort of a pipeline, or it could be infrastructure as a code via Terraform or something of that sort. The entirety of it. I'm not talking about just the deployment part when I say IAC, right? But this is at the fundamental level of it. So where do all of those things run? At the fundamental level on a VPS, it could either be bare deployment to VPS, or in the VPS, or let's say in a VPS you have Kubernetes running and then it deploys pods to it, or it restarts the pods, or as it were, however the deployment is supposed to do it, right? Now you would probably not be doing that as well. There would already be something like EKS, wherein your system is supposed to do this only one thing, wherein it says, hey, I have a new copy of the code base, build a new image out of it, tag it, and push it to ECR. And once ECR receives it, there will probably be a hook that says like, hey, EKS, there is a new version that is tagged, just pull it in and start deploying new pods and ensure this is the minimum number of pods that are available. So it does its own internal juggling and all those things. It's a very abstracted out concept here. What we are trying to do right now is to understand the nitty-gritties of how it goes through. Okay. Now we will have to do a little bit of a housekeeping before we do all of these things, which is to start writing the scripts that I was mentioning, which is your script that watches for changes internally, and then one more script that says like, hey, I do see some changes in locally that have not been pushed. You know what? Somebody has committed the changes. I'm going to push those changes to your remote. Why am I using the second script? That is purely for my ease of use. For example, when I do something like the Beetle program that I'm working with at the moment, my focus is purely on building a feature, making the code changes for it, test it. Locally, I do a mental test of the feature before I figure out, okay, this is how I want to do it. And then I build the feature. Now my build script tells me right then saying that, hey, things are good because it's running. Nothing has broken because I have a set of tests and inputs and outputs that I'm expecting. So things are in place there. Once it is tested, my comments generally are golden to go, except in certain cases where post deployment, in some kind of an exceptional case where I ensure that I encounter some kind of a failure. Barring that, my commits generally are gold to go. So what do I do? I don't want to keep saying that, okay, I commit, I push, I commit, I push, right? I have a script that looks for changes to my Git history. And then if it sees any commits that are not pushed, it pushes to my remote. Not just that, my make is also in some sense for my Beetle project. It is set up in such a way that it has one target which does a remote deploy as well. Where should it be is a matter of preference. I've kept it there because I started it there. It could be part of your git push the watcher script as well to say that, hey, do a git push to the remote and then initiate a remote build and a deploy, right? So what do we do first? I am starting with creating a directory to work with things, and mkdir-p, in case you are not aware, creates a directory if it does not exist. So basically, when I say x a/b/c, it creates all the directories in the entire chain. Now it has created the directory. If I look at it, CI/CD example. Did I? Okay, that's funny. Yeah, I did. Now I'm gonna go into the directory and the scripts. Nothing is there. Perfect. So what do I do here? I am using nvim as my primary IDE slash whatever it is. It's some sense for me to ensure that I'm remaining in the terminal. Your mileage may vary. Main.c, make file, script slash watch for changes. So these are the three files. Main.c is my source file. Make file is my standard C build make file. And script slash watch for changes is going to be the script that we're going to write that will look for changes in any of these files and then restart the compilation. Okay. It's a very simple program right now, nothing fancy. std.io.h, int main, int argc, argv, if argc less than 2, if printf. I'm clearly not able to spell today for some reason, but be that as it may, let's proceed. Return 1. I'm just going to throw an error saying that, hey, there are not enough arguments here. Error queue message not enough. Rather, so what am I doing here? I'm creating a program that takes in n number of URLs that just spits out the same URLs because it's an example thing. I don't want to go elaborate into it. I'm just going to take in a little list of URLs as arguments and then print them out as JSON. Provided. Okay, done. For unsigned int I equals 1, I less than argc, I plus plus, printf, URL. This is a contrived example, to be very honest. So you can choose to do whatever other language that you're working with and go ahead with the similar process of doing it. CC is clang, DAR is mk/p dist. And if you're wondering about the at the beginning of it, it is to ensure that the output from that does not come into the terminal output. And this is how you say that, hey, this step requires this step requires this step as a prerequisite. At cc -o CI/CD example main.c, o3, run, build. I don't need this, I'm sorry. CI/CD example, https google.com. Doesn't matter much as it's an example at the end of the day. Whatever this file. Now comes the beautiful part of writing the script. So this is something that I have not memorized. So I'm going to be either A, looking up for other scripts that I've already written, or fumble around a bit. Here with me. User bin bash. No, env bash. There are very nice tutorials on how to get along with bash, this entire ecosystem of built-ins and tools. If you are interested, do let me know in a comment. I will make further either short videos or like short video of one tool at a time, or a longer video about how do you tie these things together. One beautiful video that I would suggest you to look at is the Unix video, wherein it's a very old video from the 70s where they explain how the AT&T Bell team wrote smaller scripts rather, or binaries, or however you want to call it, right, and tie them together to build a larger usable functional product, right. It's a very nice way to organize your mind around building small and then expanding it out into a larger product as well. So I would link that as well in the video. uh, so what do I do here? So how do I get the current script? Bash underscore source 0. So this gives me the current script's name slash path. What do I need right now? The current, because I have to look into changes in any of these things, including any changes in the scripts directory itself, right? For any builds or any of those things that I would want to do. This is up to you to watch on this also, but I am choosing to do it this way. Scripts underscore dir is dir name. So this is going to give me the, but it would give me the relative path. So what do? I'll do a real path on it. Perfect. Now, what do I do here? App dir is dir name of scripts underscore dir, because the script is inside my CI/CD example. Just to ensure that this works as it is perfectly, let's just verify this. Scripts underscore dir, app underscore dir. Okay, that is probably because this was not touched. Let me try that now. Okay, can't open file for writing, no such file or directory. Or is it because I am outside the path? Let me verify that once. Yeah, so that explains it. I opened nvim from outside. So what I'm going to do right now is move these into this path. So let me do this one small change here. I will do this, tab edit. Always be sure of which path you work out of. Okay, perfect. Now we have this script that is, bear with me on this. I will just let this thing go. Let me update my nvim. Perfect. Let me go to watch for changes and do a chmod on that to make it executable. Are we good? Yes. Scripts is there. The app path is also there. Perfect. Now, What do I do? I am, I mean, I am assuming here that fswatch is already going to be installed. It will not be part of the script that to go and check, hey, if fswatch is not installed, push the user to install it or automatically install. None of those things are going to be as part of this script. So here, app dir/star.c, because this is my source file. This is my make file. I'm looking for all files inside the scripts there, right? And I'm going to do this flag O. Okay, now I do need a little bit of help from my previous script. While read, yeah. If there is any change in any of these files, do for the time being, let me just do this. Okay, perfect. Now we are listening on these. Let me see if I can make any changes here. So you see a change there in the terminal here. Yes. So whenever there is a file change that gets saved in any of these files that you're watching, this is going to be triggered. Perfect. Now, what do I do here? Instead of this, I could do this. I could just let the make file and the make targets do all of the changes. While there is a change, build make run. What is it going to do? It's not going to change the script here, output here, because this file has changed, but we did not start it with the new. It will be a very interesting thing to see if we can inject the new changes into it when it starts. If I remember right, VLAN has a way to do it. So probably that would be a very good way to bring these two together. VLAN has a live mode wherein it also provides you a scripting mode. So if you can combine these two and write this watcher script in VLAN with the live mode, trifecta. Got it. So now we are watching here. We are going to save this make file again now. What is it going to do? Perfect. Now I'm going to change my build target. I'm going to pass it into JQ in slurp mode. What does it do? JQ is a program that takes in a JSON string and converts it into a sort of a JSON object for your terminal, number one. Number two, it's not the only thing that it does, right? It's one of the things, the starting points of it. Dash S is called the slurp mode, wherein it reads one line by one line and then converts that into an array of JSON objects. It provides something like your select, which is something that you could use to filter objects. You can transform the JSON. A lot of these things could be done. As a matter of fact, my pipeline for Crisp is majorly using JQ for a lot of operations where I do not really want to do where it started rather. Why do I need a full-fledged database? Probably not. Do I need a full-fledged language binding to do all of these things? I can just combine them together. That was the original idea there. So just throwing some light on what can be done here. Extending out, I am saving this file, the make file. Perfect. Now you see an array of JSON objects here. So this doesn't look all that great now, does it? Does it? So let us do this. Clear make run. Now it would build the file, it will run it again, but it would not clear and then run it. So what do we do here? He clears the terminal and then just an aesthetic thing. Okay, perfect now. So now we have come to the point where the build steps are taken care of. They are set up in a way that whenever there is a source file change, things get built, right? Now, why do we do only this? Let's do something a little different. make their libs. Oh, touch lib slash, let's say process.h, or let's say http.h. Tab it to libs http.h. This is not by any means a C programming tutorial or any of those thoughts. I'm not getting into any of that. Just I've been working with C for a while now, and it's been easy for me to work with. So I'm just using that to start with. Like, so stdio would also have its own pragma one, so I'm not worried at the moment of including it everywhere, just to keep it clean. Okay. So what am I going to do? Int count for unsigned. Why do I do that? I could do this. Okay. I would include that here. Include lib slash ttp.h. Now I would have to create another slice. So let me change the signature there a little bit maybe. I would just retain the same thing there. I would change the argument that go in there. Now, but before I save the file, let me restart this script by adding the libraries to the watch bar. This is a mistake. I didn't realize that one. Okay. Now I am restarting this. I am saving this. That is because my path is wrong there. Perfect. That is not a problem. Let us change the path here to be just .h and not /h, which doesn't make sense at all. And this is wrong because my argument changed. All right. So the same output should come through now. Perfect. Now here comes the other beauty. Just to show that right, I am doing a tab edit libs demo.h hash pragma once. Okay, void just say demo underscore start. And what does it do? Since the output is going to go into JQ, I would be printing out a test message just so we don't break the. So the problem here has been the fact that this watcher does not look for any new files that come. There's a odd reason. So let me see what can be done there. That's something that is pretty interesting. Oh, or is that the case? I do not think so. We try this. rmlibs and demo.h. This. So let us do the red green in some sense. And what is the function there? Demo underscore start. It is not called that. Which function works when it's not called? Perfect. Now, when I save this, there should be another line in the JSON which shows message demo started. Perfect. So it does work, just that I was not plugging the file in properly. Rather, I was not calling it function. Okay, now that this entire part of this continuous build is taken care of, next we move on to the part where we deploy the changes, build it, and finally do a deployment, as you call it, a continuous deploy.